Hello everyone. In the last lecture I discussed about machine cycle, T states and timing diagram. So what is timing diagram? Timing diagram is the graphical representation of all the necessary steps that a microprocessor carries out in a machine cycle is the timing diagram. So let's see how many types of machine cycles are there. So in a 8085 microprocessor, there are 7 basic machine cycles. They are opcode fetch machine cycle, and in bracket I have mentioned the T states, that is 4 T states or 6 T states, because in some instructions you will get to see that the opcode fetch machine cycle has 4 T states, and for some instructions you will get to see the opcode fetch machine cycle has 6 T states. Then the second one is memory read machine cycle having 3 T states, memory write machine cycle having 3 T states, input output read machine cycle having 3 T states, input output write machine cycle having 3 T states, interrupt acknowledge cycle, and bus idle cycle. So we're going to see the timing diagram for all these machine cycles. Let's start with the opcode fetch machine cycle, the timing diagram for this opcode fetch machine cycle. So this is the timing diagram for opcode fetch machine cycle. Means these are the necessary steps that 8085 microprocessor carries out for fetching the opcode from the memory. Now how the microprocessor fetches the opcode from the memory, let's just see the process. So what happens, this is the 8085 microprocessor. So what happens, the 8085 microprocessor first sends the address through the address bus to the memory. Now how it sends the 16-bit address? The higher byte of the 16-bit address goes through the address bus A8 to A15, and the lower byte of the 16-bit address goes through the address data bus AD0 to AD7. Now since AD0 to AD7 is address data bus and it needs to be get free for carrying the data, so the address that is coming through this address data bus needs to get latched either into the memory or into some external device. So there is a latch here which latches the lower byte of the address and makes the address data bus free for carrying the data. Now the 16-bit address goes to the memory, and once it reaches the memory and the memory gets the memory location, it finds the opcode. What it does, it stores the opcode into the data bus, and from the data bus the opcode goes to the microprocessor from where it gets stored in the instruction register. Now this opcode gets stored in the instruction register after traveling through the data bus from the memory, where after the data, or you can say the opcode, goes to the decoder where it gets decoded, and after getting decoded, accordingly microprocessor allows the timing and controls unit to make necessary signals to decide whether the instruction should get executed or not, or whether where more machine cycles are needed or not. Now if it is a single byte instruction, then the whole instruction will get executed in one machine cycle only. But if it is 2 or 3 byte instructions, so after decoding of the opcode, it will need more machine cycles for the complete execution of the instruction. Now let's go back to the timing diagram. Now see how the signals are being displayed. Let's see. So what happens, there are 4 T states in the opcode fetch machine cycle, as I've already told you. generally in many of the instructions you will get to see the opcode fetch machine cycle has 4 T states, whereas in some instructions you will get to see the opcode fetch machine cycle has 6 T states. Now let's first talk about the 4 T states opcode fetch machine cycle. So in the first T state, microprocessor, what it does, it makes the IO/M bar low and S0 and S1 pins high. Why it makes S0 and S1 pins high? As I've told you when I was discussing the pin configuration part, that S0 and S1 are the status pins and they tell the current operation that is in progress in the 8085 microprocessor. So when both the S0 and S1 are high, it means the opcode fetch machine cycle is being executed. So for opcode fetch machine cycle, microprocessor makes S0 and S1 pin both to be high, and it makes IO/M bar low, means it is activating the M bar, which means the address that it is going to send through the address bus, it is for the memory, that is only memory should react to that address. Now in the first T state only, microprocessor sends the 16-bit address, that is A0 to A15 16-bit address through the address bus. Though it sends the higher byte of the address through the address bus A8 to A15 and the lower byte of the address through the address data bus AD0 to AD7. Now since AD0 to AD7 it is an address data bus, it needs to be get free for carrying the data, means the address which is currently present in the address data bus, it needs to be get latched into some external device or into the memory so that it gets free for carrying the data, that is address data bus gets free for carrying the data for rest of the T states. And how it takes place, microprocessor in the first T state only, it activates the ALE signal, that is it makes ALE signal high, address latch enable signal high, which tells that the address, that is lower byte of the address in the address data bus to get latched either into the memory or in some external device and make the address data bus free for carrying the data for rest of the T states. Now what happens after the memory receives the address, 16-bit address, it searches for the memory location and it finds the opcode. Once it gets the opcode, what happens in T2 state, microprocessor makes the RD bar signal low. Now as I've already told you when I was discussing the pin configuration part, that when the RD bar signal gets activated means some data will go either from memory to the microprocessor or input output device to the microprocessor. So here we are talking about memory, means some data will go from memory to the microprocessor, means reading operation is being performed by the microprocessor. So in T2 state, when microprocessor makes the RD bar signal low, the opcode which was found by the memory, it stores that opcode in the data bus and it sends that data through the data bus to the microprocessor. So in T3 state, once the data reaches the microprocessor, it gets stored in the instruction register of the microprocessor. Now once it reaches the instruction register, what happens, microprocessor makes the RD bar signal high, means it is deactivating the RD bar signal, which disables the memory. Now after the opcode reaches the instruction register in T4 state, from the instruction register the opcode goes to the instruction decoder where decoding of the instruction takes place. Now if it is a single byte instruction like MOV AB, where all the data are present in the general purpose register of microprocessor, then the execution of the instruction will take place in the T4 state only, and the whole instruction will get executed in the 4 T states, that is in opcode fetch machine cycle only. But if it is a 2 byte or 3 byte instruction, then after decoding of the opcode, it need more machine cycles for the total execution of the instruction, like memory read cycle or memory write cycle or input output read cycle or input output write cycle. So this was all about the timing diagram for opcode fetch machine cycle. So here I have also shown that for opcode fetch machine cycle, as I have already told you, what will happen, IO/M bar will be low, S0 and S1 will be high, and there will be four T states. Sorry, this is the T state. There will be 4 T states in the opcode fetch machine cycle, and RD bar will also be low for the opcode fetch machine cycle. So I'm ending this class here. In the next class, I'll be discussing about memory read machine cycle and input output read machine cycle.